So with this variation problem, we're told that the volume of a fixed amount of gas varies directly as the temperature and inversely as the pressure. Okay, so that tells us that the volume is going to change directly as the temperature changes and inversely as the pressure changes. Now, you might recognize this from chemistry as a version of the ideal gas law. And a big part of what I remember from chemistry is manipulating the ideal gas law formula. So this will come in handy when you take chemistry. So let's see what we have. We're told, first of all, something about the volume, and that it varies directly with the temperature and inversely with the pressure. So that means that the volume is equal to a constant, and since it's directly with the temperature, it would be K times T, but inversely with the pressure. So this would be over P. So this is a formula that tells us how the volume is related to both temperature and to pressure. So the volume of a gas is equal to some constant multiplied by temperature divided by pressure. So knowing that, we can answer the second part of the problem. So we're going to suppose that the volume is 120 cubic centimeters, temperature is 126 Kelvin, the pressure is 13 kilograms per square centimeter. And then we want to find the temperature subject to these constraints. Well, the first part in doing a problem like this is coming up with this formula. We have this formula now. And the second part is figuring out what this constant is. Well, we're given the volume, we're given the temperature, and we're given the pressure. So if we plug all of those values in, we can solve for K. So let's do that. Let's do that. If we take the volume equals 120, so in this equation, we will have 120 equals K. Don't know what K is yet. Temperature is 260, and the pressure is 13. So now we just need to solve this equation for K. 13 will go into 260 20 times. So that's going to give us 120 equals K times 20. Divide both sides of this by 20. 20 will cancel out. And over here on the left, the 20 will cancel with the 120 to leave 6, which tells us that K equals 6. All right, now using this information, that K is equal to 6, we can rewrite the volume equation from here as the volume is equal to 6 times temperature divided by pressure. Now that will let us answer this last thing. Find the temperature when the volume is 152 cubic centimeters and the pressure is 15 kilograms per centimeter. So let's do this last part of the problem. So the volume is going to be 152. That's equal to 6. Temperature is what we're trying to find, and the pressure is 15. All right. So we're just solving this equation for T. So first thing we can do is multiply both sides of the equation by 15 to get rid of that fraction in the right-hand side. So 6 times T over 15 times 15. The 15s will cancel out. We can use a calculator to get that the left-hand side is going to be 2,280. So 2,280 equals 6T. Let's divide both sides by 6. And using a calculator again, we'll get that left-hand side. 6 will cancel into 2280 and leave, let's see, let's use a different color so I can see what we're doing. So that'll leave 380. And putting all this together, we'll get that T temperature will be equal to 380 Kelvin.